Welcome, everyone. Welcome to this presentation on free software on GSM smartphones. This presentation is basically going to be two presentations. The first one is presented by me, and it's about the what I call OpenEasyX project, which is related to Motorola Linux-based smartphones. And there's a second part which will be presented by Smurf on the HTC Blue Angel-based, Linux-based mobile phones. First of all, to clarify any kind of misunderstandings, in any of these phones, Linux is not running the actual GSM stack. So if you think this is a presentation that is about the GSM stack on Linux, then this is not true. It's merely a GSM mobile phone that also runs Linux on one of its CPUs. So if this is now disappointing to you, you can still leave and go to another presentation. Okay. So first, a little bit of background about myself. I'm working as a free software developer, also freelancing, so earning my money actually off free software-related development for quite some time. Mostly known for NetFilter IP tables and GPL enforcement work, but recently have started to hack on those Motorola EasyX GSM phones that are based on Linux. This is about the contents of the presentation. So let's start with a short disclaimer. I have no affiliation with Motorola. The OpenEasyX project has no affiliation with Motorola. All information is based on observation and may be wrong. And lots of the work has been done by a large community. So I'm basically a newbie to this community who works with the Motorola mobile phones. This is partly due to the fact that most of the Motorola Linux-based phones, at least all of the past models, have only been sold in the Asian market. So it was virtually impossible to buy any of these here in Europe. And only this model, it's the Motorola A780. It has been introduced to the European market so far. It has been introduced, I think it was in September this year. The Chinese, in the Chinese market, there have been Linux-based Motorola phones for more than 1.5 years now. So that's why there's lots of, especially Chinese developers who are hacking on this phone for quite some more time than I had the chance to. So the goal of this OpenEasyX project is basically to document the phone, to find out about the phone's hardware and software architecture, and to replace the proprietary software that is running on Linux and the proprietary drivers, or well, not actually drivers, but we will talk about this, the proprietary pieces that they have on their Linux-based operating systems with 100% free software. And there's a certain group of people who are also interested in, once this has been done as a foundation, to actually go and look at the GSM and RF-related parts of the phone and look into whatever kind of nice games you can do with these parts. The project homepage is openeasyx.org. There's not really all that much about that there. Most of the information is contained in the wiki. If you have any information to add, you're always welcome to contribute to that wiki. As I said, there's been a number of Linux-based GSM phones in the Asian market as early as 2003. That's the A760, A768, which look very similar to this A780. So it's the same flip kind of design for a phone. And now we have what Motorola calls the EasyX architecture. It's A780, the phone I have just shown. There's an E680, which looks like this. So it doesn't have this kind of flip design. It's an uncovered, unshielded touch screen on the front. But it's basically the same kind of hardware. I'm going to talk about differences later. So the E680 is only sold in the Asian market. This particular model I managed to buy from a Chinese guy who has moved to Germany and buy it on eBay here in Germany. Otherwise, I wouldn't be able to have that one. So, as I said, A780 is now available in the US and in Europe. Interestingly, the GPS functionality is only present in the European models. So neither the Chinese nor the US models have the GPS receiver, but the European do. I don't know why that is. So what is it, the A780? It's a quad-band GSM phone, so it works with all GPS networks on the planet. It has an AGPS receiver for, location services and so on. It has GPRS, Edge, HSCSD. It's based on an Intel X-Scale architecture. It runs a Monta Vista consumer electronics Linux. It has Bluetooth. It has a USB device port that can be, well, officially can be used for modem emulation and mass storage, so you can access the flash file system. And it has a TransFlash slot. TransFlash is the latest incarnation of flash memory chips. It's from a logical and electrical level, it's compatible to SD card, but the physical dimensions, the physical characteristics are different. Okay, so the E680 is almost like the A780. It doesn't have GPS. It has a full-sized SD or MMC card slot. It has an FM radio. I don't know why they removed it in the A780. And it has minor differences in the audio subsystem, and a number, a handful of GPIO pins are differently assigned and so on. But in general, it's almost exactly the same piece of hardware and software. So actually, you can. Also, the E680i is basically an E680 with a more current firmware. So you can flash an E680i's firmware onto the E680. That's what I'm running here. It works perfectly, and you have all the features of the new phone. I don't know what, marketing stuff. Anyway, so what did I do, or what did the others do when learning about the device? So obviously the first thing with any kind of device I do, since, I don't know, I'm 10 maybe, or even earlier than that, I had to take it apart. So the first thing I did is take the phone apart, take high-resolution PCP photographs, which tend to be useful if, especially mobile phones don't tend to work when you disassemble them. So you have to put all the connectors and different PCBs together again when you actually want to run them. And then at a certain point, you want to find out what is this, or what is going on. So you look at the high-res PCB photographs. The FCC database sometimes is helpful. Unfortunately, most of the really interesting information that is submitted to the FCC is confidential. So the full schematics and everything that have to be submitted by the vendor are not public, but you get, even though you get some interesting information about the hardware from the FCC database. This particular phone, obviously all kinds of radio frequency equipment have shielding, but this particular phone, the shielding was not, it was actually soldered on the PCB. So I had to unsolder all the different shielding covers. There's 7 or 8 of them on the phone. Look at what is there, the integrated circuits, try to Google for the circuits, try locate data sheets for those that are available. Also, the level 1, level 2, level 3 service manuals sometimes can be obtained from websites that offer them for like $5 or $9, websites where the business is to sell service manuals. Obviously, the service manuals don't go very in-depth, but still, it's a starting point. One of the things I always do when looking at embedded devices is try to locate a serial console port, which in almost all kinds of devices that I've looked at so far was quite successful. But in this particular mobile phone, there is none. I can now prove there is none because I know, well, I own the device. I have no root access, but I own my own phone. Isn't that nice? Anyway. So there is no serial console, but I didn't know that, so I was actually checking all the more than 100 test pads on the PCB individually with an oscilloscope by powering on and looking at the signal that happens to be at that pin when powering on the device. As I said, usually you find something that looks like a serial port, but in this case there was none. Another approach is obviously to find a JTAG port, and there are certain, well, if you see 5 pins in a row, then it's very likely that that might be JTAG. As in 5 pins, not 5 test pads. Obviously, you don't have any connectors or that kind of stuff because there's no physical space for it. Obviously, even if you find a JTAG port, it's only useful if you get a BSDL file or something similar. Luckily, this phone runs an PXA270 X-Scale processor from Intel, where you can download the BSDL file from the website. If you don't know what BSDL is, it's called the Boundary Scan Description Language, and it basically describes the boundary scan cells that are embedded for the JTAG debugging port. And by using the BSDL file, you can actually interpret the information that you send or receive from the JTAG port. Also, be aware there might be multiple JTAG ports for multiple ICs. So this phone has 4 different processors. I'm going to show that in a couple of minutes, and obviously each of them can have its own JTAG port. So even if you find JTAG, it might not be the JTAG you want to speak to. So what we actually want is access to the OS instead of the user interface. I mean, the phone is nice, you know, you have a touch screen, you can click on buttons and so on, but it's a Linux phone and you don't really have access to Linux. So a serial console obviously helps in many cases, not in this one. Network devices sometimes have Telnet SSH available. Also, sometimes there's software installed that is known to be exploitable. So this phone ships with CLIP 1.1.3, which obviously, I mean, anyone who has any idea about security holes, this CLIP has at least 2 documented exploitable vulnerabilities. So actually you could, I didn't do that, but I think it is feasible to write a zlib compressed PNG image which contains shellcode to exploit the library and to basically, so then you open the Opera web browser on the phone which links against zlib and decompresses the JPEG image and so on. So it should be possible to exploit the device using that path. I didn't try it. Weird button combinations that start up are also quite interesting in the case of these phones, because if you press 3 particular buttons, then you end up in a blue screen. It's a blue screen. It looks a little bit like a Windows blue screen, but that's actually the bootloader. So by pressing certain buttons, you end up in the bootloader instead of the OS, and then you can try, you know, what the bootloader has, what kind of features you have. Access to flash memory over JTAG is also a possible attack vector. So you can, if you have JTAG and JTAG is working, you can read out the flash memory. You can do whatever you want. If you manage to have shell access, you can just, you know, copy the whatever MTD devices that you have. You can also sometimes, using vendor-supplied flash programming tools, you can read actually files. In the case of Motorola, I'm not aware that there is Motorola software for reading firmware images. There obviously is for writing, but not for reading. If you have a copy, well, then you just copy unmount, unpack mount, and so on the PC workstation. What you can also do is run ARM. Once you have an image, then you can start running the binaries, for example, in QEMU and software emulation. Obviously, there's commercial ARM emulators as well. Disassembling, you know, might be illegal in certain jurisdictions. You can use GNU-Pinutils, IDE Pro, and so on. You all know that. So, what have we found out about this phone? Okay. In short, it is a Neptune LTE-based mobile phone plus a PXA270-based PDA in one case. So this is actually at least 2 totally separate devices that are on one PCB and that talk to each other. But it's really, there's no real integration. So you have the real, this Neptune LTE is a chipset that is also found in non-smartphones from Motorola. So if you buy a Motorola Razr or a Motorola E398 or something like that, then you basically get only the phone part and not the PDA part. But it's the same chipset, it's the same, well, very similar piece of software running on there and so on. The RF part will be similar. So they just took an existing phone design and put a PDA in front of it and interconnected them over USB. So there's actually a USB port that is just on the PCB of that device, which runs between the front-end processor and the back-end processor. So the front-end processor is called application processor. It's a PXA270, runs a heavily modified 2420 kernel, 48 megs of RAM, 48 megs of wireless flash. Who has heard about wireless flash before? Ah, yeah, somebody over there. So wireless flash means that the flash is actually bonded onto the same chip as the CPU, so you don't need to route wires on the PCB between the processor and the flash. So that's why it has no wires. It's wireless. Anyway. The clock speed runs up to 400 megahertz. This phone runs only at 200 megahertz for power consumption reasons, but the Game Boy emulator that now exists obviously increases the clock of the CPU to be, to perform better. So you can do that using software. There's a JTAG port, which has been documented. We have the BSDL file. There's a JFlash program you can use to flash